This video is on quadratic applications. Alright, so if we take a look at this example, it says the height of a golf ball hit from the ground. Alright, so let's draw a picture here. We have somebody, here's the ground, and they're golfing, and then here's the golf ball. It says the height of a golf ball hit from the ground can be approximated by this function, where t is the time. So we know that t is the time, so then the h here must be the height of the ball. And h is the height in feet of the golf ball. It asks, what is the height? So that means I'm going to find h. So it says, what is the height of the golf ball in 2 seconds? So then they gave me here the time. So time is 2. So again, you always read the question and you think about what's going on. So we have this person, they're going to hit the golf ball, so the golf ball will go up in the air and then it will come down. And it wants to know, when will the golf ball be, or what is the height of the golf ball in 2 seconds? So where will it be in 2 seconds? So we're going to take the equation that we're given. So h of t equals negative 16t squared plus 100t. And it wants to know, find the height. So we have to figure out the height when we plug in 2 for t. So we're not solving anything here. We are just using substitution. So order of operations, we do the exponents first, and then we do 4 times the negative 16 here, which that is negative 64. And then we have 100 times 2, and that is positive 200. And then we have negative 64 plus 200. That is 136. So we just found the height. The height is 136 when the time is 2 seconds. So it says, what is the height of the golf ball in 2 seconds? We would say 136 feet. Okay, so then we're asked to find the maximum height of the golf ball. So if we go back to our picture, now it's not asking where is it going to be in 2 seconds. Now we want to know this. When is it going to be? So it says find the maximum height. That means that we want to find h, that the golf ball reaches. Now notice they didn't give me any number in this problem to plug in. Well, that's because we have learned in section 9.5 how to find this point right here. It's called the vertex. So it's asking us to find the vertex. So we know that in 2 seconds it's 136 feet. We want to know, well, what if that's the highest? We want to know, what is the highest? Does it go higher than this? What is that highest point there? So we have learned to find the vertex, so the highest point. To find the x value, we do negative b over 2a. However, in this problem, they don't use x, they use t. So this is going to get us t, not x. So we're going to use negative b. So let me copy down the equation again. So a is the number in front of the squared term. This is b, and then c would be 0 because there is none. So we would have negative 100 divided by 2a. So negative 100 divided by negative 32. So negative 100 divided by negative 32. We get 3.125. It doesn't tell us to round it, so I'm going to keep all those numbers there. So it says find the maximum height. Well, what we just found was t. That's the seconds. It didn't ask for that. It said find h. So we just found that it's 3.125 for the seconds. So now to find the height, we're going to go ahead and plug in the 3.125 for the t. So we're going to plug in the 3.125 for the t. Running out of room there. Okay, so we're going to do 3.125 squared. And we would get 9.765625. It does not say to round. And then we're going to multiply that by -16. So I'm just moving this over here. So times -16. And we would get -156.25. And then we'd have here multiplication here. So we'd have 100 times 3.125 over here. So 100 times 3.125. So positive 312.5 there. And then we're going to enter this in our calculator, -156.25 plus 312.5. It'd be 156.25. So what we just found was this. We just found the height of the ball will be 156.25 feet. So it says find the maximum height. So it'd be 156.25 feet is the maximum height. So it says find the maximum height. So that's the maximum height right here. So at 2 seconds, it's below. It's at 136. And then when it gets here, it's going to be 156.25 feet at 3.125 seconds. So in 2 seconds, it's this height. And then in 3.125, it goes higher. It goes to this. So this is the highest the ball will ever reach. Okay. Then we have part C. It says, when will the golf ball reach the ground after it's hit? So it says when. So when means find t. We don't know what t is. When will the golf ball reach the ground? Well, the ground is when the height is 0. So we're going to take our function, and we're going to go ahead and plug in a 0 here because we want to know when, so that means find t, will the height, when will the golf ball reach the ground after it's hit? So we already know that the golf ball is already on the ground. So we want to find when it goes up and when it will hit the ground here again. So we already know 0 is an answer, but we're not going to include it because it says when will it be on the ground after it's hit. So we need to solve this equation here. So we could divide everything by 4, because 4 goes into 16, or -4. Or what we can do is factor this. They both have t's. So I'm going to go ahead and solve by factoring. So I know 4 goes into both of these. I'm going to pick -4 because I don't ever want this to be a negative here. And they both have t's in common. So -4t times 4t makes -16t squared. And then negative times a negative times a negative is a positive, and then times 25. Okay, so then now that it's factored, we're going to set each of these equal to 0. So we're going to have 0 equals -4t, and 0 equals 4t minus 25. So we're going to go ahead and divide by -4 here, and we would get 0 equals t. And then we're going to add 25, and then divide by 4. And we have 25 divided by 4 is 6.25 for t. So remember, t is seconds. So it says, when will the golf ball reach the ground? Well, at 0 seconds, we already knew that. So it's going to hit the ground here at 0 seconds, and then here again at 6.25 seconds. So it says, when will it reach the ground again after it's hit? So we would just write 6.25 seconds. So again, the reason why we're not going to include this one, because it says after it's hit. So this is to begin with. The golf ball is on the ground, and then this is after it's hit. Okay. All right, part D here. It says when, so that means we're finding t. It says, when will the golf ball reach a height? So we know to plug in 114 for h. So it wants to know, when will it be 114 feet in the air? So we already know at 2 seconds it's 136. So we know it's going to be less than 2 seconds, because at 2 seconds it's 136, and we want to know when it's going to be 114. So we know, just based on the previous parts, that it's going to be less than 2, this answer. So we're going to go ahead and take our function. And we want to know when the height is 114, so we're going to plug in 114 here. And I'm going to go ahead and make this equal 0. Now they're all even. So if I want to make the number smaller, you don't have to. I can go ahead and divide everything by 2 or -2. Whatever I do to one side, I have to do to the other. And then we'd have 114 divided by 2. That's 57. Okay. So now I could either try to factor it, but because these numbers are larger, I'm going to actually use the quadratic formula. So remember, that's -b plus or minus b squared minus 4ac all over 2a. So I'm going to have -50, plugging in the numbers. So I'm going to have 50 squared, and then we're going to have -4 times 8 times 57. So then we have 2,500 minus 1,824. We get 676 in the radical. And now I'm curious, what times itself is 676? Nice, it's 26. So now we can simplify this. This equals 50 plus or minus 26 all over 16. So then we would get 50 plus 26 divided by 16, and we get 50 minus 26 divided by 16. So let's go ahead and see what that is here. So 50 plus 26 divided by